A circular loop has its radius increasing at a rate 3 meters per second. The loop is placed perpendicular to a constant magnetic field strength 0.5 Weber per meter cube. When the radius of the loop is 6 centimeters, the magnitude of the induced EMF, what is the answer? That is the thing we are going to solve it now.
First, we need to write the given quantity in this problem. A circular loop increasing radius at a rate 3 meter per second. That means they are given the dr by dt, rate of change of the radius, it is equal to 3 every second. It is increasing as a 3 meter. The loop is placed perpendicular to the magnetic field. That means suppose if this is a loop, circular loop, the radius is keep on increasing. It is placed perpendicular to the magnetic field. That means the angle between the area of the loop as well as the field line, it is perpendicular. This is the magnetic field direction. So the magnetic field intensity or magnetic field strength they are given, it's a 0.5 Weber per meter square, and the radius of the loop, so when r equal to, it is 6 meter, then the magnitude of the induced EMF they are asking. These are the given quantity: rate of change of radius, then b, then radius if it is 6 meter. What is the induced EMF they are asking? So we know the formula for the induced EMF, that induced EMF is equal to, that should be equal to epsilon naught in general, or the induced EMF is equal to, in general you can write d pi by dt, the rate of change of flux, that is the induced EMF. So whenever the flux is changing, then there is an induced EMF in the loop of the coil. So the flux in general, this is an induced EMF. Maybe you can put the minus sign according to the Lenz's law. So induced EMF, that should be equal to minus d by dt of the magnetic flux. You can write it is b dot d, integral of, this is a flux, the magnetic flux. That means the flux linked with any closed surface area, that should be equal to integral over b dot the dA or ds, that is the net magnetic flux through the surface area. If the magnetic field is constant, then you can take it out and then you can do the integration. So if the magnetic field is constant, you can take it out of the differential. So d by dt of, if I taking integral of dA of this loop, that means the area of this loop of radius r, that should be equal to pi r square. This is the area of the loop. So magnetic field is constant, now it is outside. Now what we have to do, the induced EMF is equal to b, pi is also constant, you can take it off, d by dt of r square, because our radius is keep on changing. You have to differentiate r. If you are differentiating r, it will give dr by dt. So the induced EMF is equal to minus b times 2 pi, or they given at 6 meter, dr by dt also they are given, that is equal to 3 meter per second. B also it's given, that b value it's 0.5 above meter per meter square. So the induced EMF is equal to minus 0.5 times 2 pi, 3 6 are 18. If you are multiplying this quantity, the induced EMF is equal to 0.5, you can write it as 1 by 2 times 2 pi into 18. So 1 by 2 will get cancelled. In general, it will be equal to 18 pi volt. It's a negative. It will opposes whatever the changes causes externally. That is the meaning of the Lenz's law. So 18 pi volts. This is the answer for this question.
From the calculation, we got the answer that is 18 pi volt. The option C is the right answer.